Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be answering questions from question number 5, from the June 2024 Pure Mathematics P4 paper from Edexcel International A-Level. And this question here, we have a curve. It says figure 2 shows a sketch of the curve defined by parametric equations x equals t squared plus 2t, y equals 2 plus 2 over t times 3 minus t in brackets in the denominator, and t has a range of values or interval between a and b, including a and b. All right, so this is a curve defined parametrically. So it's defined not just y as a function of x, but it's, you have x, you have y, and you also have a third parameter, t. That's why it's called parametric equation, because it has an extra parameter. So you have the x and the y, parameters, and the t parameter, which define this equation. And it says the ends of the curve lie on the line with equation y equals 1. So this is the line y equals 1. And the ends of the curve lie in those points. The curve only exists between those two values of t. Okay, and it says we got to find the values of a and b. Okay, so I have the kind of little sketch here to make it. I have to keep scrolling up and down. But basically, we want to know, the values of t when y equals 1. That's basically what we want to find. So we can use this section of the equation, the one that involves y and t, and we say, okay, when y equals 1, you have 2 over t times 3 minus t is equal to 1. So you have 2 equals t times 3 minus t just by cross multiplying. Y equals t times 3 minus t, and we have to solve this equation. So we see we're going to have a quadratic. Okay, don't make the mistake that many people make, say 2 equals 3 and 3 minus 2 equals, t equals 2 and 3 minus t equals 2. No, you have a product of two factors. When they equal 0, then one can be 0 or the other one can be 0. If they equal 2, they could be anything, right? Product of two factors equals 2. The values of those two can be anything. But if you have two factors multiplied together to give you 0, then either one of them is 0 or the other one is 0. One of them has to be 0. So that's why we use a zero product property. So we cannot use that here. Some students, even in A-levels, they kind of make such silly mistakes. So here we got t times 3, which is 3t, and t times minus t, which is minus t squared. So we have a quadratic here. So what I'll do is I will add t squared to both sides and subtract 3t from both sides, such that I'll be left with an quadratic equation with the t squared term positive. Now I have to express this as a product of factors, so I can use a zero product property. And this is pretty simple. We have two brackets, and this factorizes quite easily. We know we have to have two negative signs because the product is positive and the sum is negative. And it must be minus 2 and minus 1. Because you multiply them together, you get positive 2, and you do minus 2 minus 1, you get minus 3. So we end up with t either equals 2 or t equals 1. So we can see from here that a is the one that's, the lesser value. So a must be 1 and b must be equal to 2. And we have answered part A. It says find the values of a and b. Okay, so that's the answer to part 1, part A of this question. Now we're going to go to part B. So it says the region R, shown shaded in figure 2, is bounded by the curve and the line with the equation y equals 1. Show that the area of the region R is given by this m minus k times the integral between a and b of t plus 1 over t minus 3 over t times 3 minus t, where m and k are constants to be found. All right, so we already know the values of a and b. Okay, so we got to find the area of this region here. Now, we know if we integrate a function, between two here, if we integrate this between these x values. So this is like x1 and x2. If we integrate between these two x values, okay, we're going to get the area under the curve. So if we integrate the function, you know, if we have it as y as some function of x, and we integrate it between these values of x, we will get this area. Okay, well, we want the area above it. So if we find the area of this rectangle and take away the area under the curve, we will get the area of R. Okay, so to do that, we need to find the x value at this point and the x value at this point. Now, this is not the x value, this is the t value, so don't get confused by that, right? We need to know what the value of x is when t equals 1. We have x equals 1 squared plus 2 times 1, which is going to be 3. So this is 3 in terms of x value. And when t equals 2, we have x equals 2 squared plus 2 times 2. Okay, which is going to be 4 plus 4, which is 8. So this value of x is 8. Okay, so we can see that the area of this rectangle will be easily found now by just multiplying the width by the height. Okay, and we can see that the width of the rectangle is 8 minus 3, which is 5, and the height is 1. So we can say that the value of m, that's probably what this is going to be here, the area of the rectangle minus that. So we can say the area of the rectangle, okay, the rectangle is equal to 5 times 1, which is 5. So that's the area of the whole rectangle. Now we want to find the area under the curve. Okay, so the area under the curve, area under the curve, which is not the same as R, but if I find that and I do 5 minus that, it will give me the answer. How do I find the area under the curve? Well, I've got to integrate between the limits of 3 and 5, okay, of y dx. If I integrate y with respect to x between the limits of 3 and 5, I'll get the area. Now, unfortunately, well, not unfortunately, but we don't have the equation in terms of x, y as a function of x. We have x and y both as functions of t. So when you're dealing with parametric integration, what we have to do is very similar to what we do with substitution. We have y dx dt dt. Okay, y dx dt, that will give us, and what I have to do is I have to also change the limits. I can change, and now this is in terms of t, so I'm not going to write the limits in terms of x. All of these, everything in here has to be written in terms of t, including the limits. So I'll call this t1 and t2. Right? So I need to find those limits. Okay, now these are x values, so I can find the limits by using this. I know that when x equals 5, okay, when x equals 5, I have 5 equals, no, in fact, I know the values of t here. I don't need to worry about that, do I? Okay, I know the value at this point is when t equals 1, and that's t equals 2. We already worked that out. Okay, we already know that from the first part of the question. So this is going to be 1, and this is going to be 2. When x is 3, actually, this is the other way around. Okay, when x is 3, we've got t equals 1. And when x is 5, t equals 2. So we have those values already. Okay, so that's no problem there. Now, y in terms of t is already written as y equals 2 over t times 3 minus t. Okay, so I can say that this is equal to the integral between the limits of 1 and 2 of 2 over t times 3 minus t times dx dt. Okay, so we got to find dx dt. So x is equal to t squared plus 2t, t squared plus 2 times t. So dx dt, okay, is going to be 2t plus 2. Right, so you're going to have this times dx dt, which is this. So it's going to be times 2t plus 2 with respect to t. All right, so we're going to have here integral between 1 and 2. That's going to be, now let's look at the form that we have to write it in, this form here. So I'm going to take this and just put it down there. So it's always good to keep in your mind the form that you have to have it. So I can see, first of all, the m is going to be my 5. So I'll put that at the end anyway. All right, that's going to be 5 we found here, but this part here I'm concentrating on. So I can see here, if I take 2 out of this, okay, out of this bracket, I'll have 2 times 2, which is 4. I'll have t plus 1. I'm looking for the t plus 1 over t times 3 minus t dt. So to put it in this form with the k there, the k is 4 basically. They've taken the constant outside, just like I like to do. So you have t plus 1 over t times 3 minus t dt. That's the area under the curve. So therefore R, the area of R, is going to be equal to 5 minus, because the area of the whole rectangle is 5, minus this area over here, which is 4, between the limits of 1 and 2, of t plus 1 over t times 3 minus t with respect to t. So there's the answer to this part B. Okay, so that's the answer. So you have 5 here and then you have 4 there, and the limits are 1 and 2. Okay, so that is part B. Now for part C, it says, first of all, it says write this in partial fractions, and then it tells us to use algebraic integration to find the exact area of R. So that's going to be for part 2, but just to remind ourselves, this was 5. So let me just do something too. We already found these values. So this was 5. Okay, and this was 4. And this was 1 and 2. Okay, so this was 5. Oops. This was 5, and this was 4, and this was 1 and 2. Okay, so that's what that's the area of R equals this. Okay, so that's something that we already derived in the first part of the question. Now, C part 1, it says write this in partial fractions. So obviously they're getting us ready to, it's teaching us how to integrate this. To integrate this, we need to split it into partial fractions. So now you have t plus 1 over t times 3 minus t. To split this into partial fractions, you're going to have something in this form. You're going to have, first of all, you check, is it an improper fraction? Well, no, because the numerator has an order of 1, linear. The denominator has an order of 2. If you expand it, it would be t squared. So you have the numerator of an order less than that of the denominator. So it's a proper fraction. So it's just going to split up into 2 proper fractions, a over t plus b over 3 minus t. Okay, you want to have a quotient part. And the next step for us is to basically multiply through by t times 3 minus t to get rid of the fractions. So we have t plus 1 is identical to a times, and what I'm going to do, if I multiply by t times 3 minus t, this term, the t cancels, I'm left with a times 3 minus t, plus, if I multiply the whole of this by t times 3 minus t, the 3 minus t cancels, leaving you with t. Basically, this is multiplied by that, and that multiplied by that. Now we can find the value of a and b. We can start, for example, let's replace t with 0. That will eliminate the b term. Okay, if you have 0, you have 1 equals 3a. So that means a is equal to 1/3. And we can also say let t equals 3. When t equals 3, the a term will be eliminated. Now 3 minus 3 is 0. So this will be 4 is equal to 3t. bt. Okay, so we can say that what am I doing? 4 is equal to 3b. T is equal to 3, so that you're going to have b times 3, which is 3b, which means that b is equal to 4 over 3. So we can say that t plus 1 over t times 3 minus t is identical to 1 over 3t plus 4 over 3 times 3 minus t. Okay, and then part 2 says we must integrate now this, okay, 5. We must find the area of this expression. So you have 5 minus 4 times the integral between the limits of 1 and 2 of basically this now. 1 over 3 times t plus 4 over 3 minus t with respect to t. Okay, so now what I'm going to do is I'm going to take out the 3 outside. I like to do stuff like this. So I'll take out like 1/3. So it'll be 4 over 3. And you'll be left with here the limits of 1 and 2. This is going to be 1 over t plus 4 over 3 minus t. Integrate with respect to t. That just, I like to make it neater like that. So you have 5 minus 4 over 3 times. Don't forget, you can't deal with this until you've multiplied 4 over 3 with what's in here because of bin mass. So I can't do anything with that. And now I'm going to integrate this. Now, the denominators are of the form, if you differentiate the denominator, you're going to get a constant. The numerator is a constant. Same with this. So we can use the reverse of the chain rule for ln. So 1 over t will give you the ln of the modulus of t. Remember to put the modulus sign there. It's very important. And you'll have plus 4 times the ln of the modulus of 3 minus t divided by minus 1. Divide by always the differential what's inside the function. Here we did the same thing, but the differential of t is 1 anyway. Right, but here, careful, there's a minus 1, which is going to change that sign. And don't forget the limits 1 and 2. Right, so now we can hopefully get our answer soon. So 5 minus 4 over 3 times, and let me simplify before I put the values of things in. So ln of t minus 4 ln of the modulus of 3 minus t, limits 1 and 2. Okay, so this is 5 minus 4 over 3 times. Now I'm going to put 2 in here, so that'll be ln of 2. I don't have to put the modulus sign once I know it's positive. Minus 4 times the ln of, that's 3 minus 2, which is 1. Okay, minus, and then I'm going to have to put 1 in here. So that'll be ln of 1 minus 4 times the ln of 3 minus 1, which is 2. Okay, so that's equal to 5 minus 4 over 3 times. So you have the ln of 2 minus, well, this is going to become 0. Ln of 1 is 0. So you have ln of 2 minus 0. The ln of 1, so 4 times 0 is 0. Then you got minus ln of 1, which is basically 0. Okay, so that's going to be minus 0 and plus 4 ln 2. Okay, so those end up being 0. So you end up with here 5 minus 4 over 3 times the ln of 2 plus 4 times the ln of 2, which is 5 ln 2. Okay, so we end up with 5 minus 20 over 3 ln 2. Now, did they tell us to give the form in its simplest form? Okay, so that's fine. We can leave it like this. If we want to make it into one fraction, we can say 15 minus 20 ln 2 over 3. Okay, where we made this as 15 over 3. And we can do it like that, but this is perfectly fine. And this is also perfectly fine. And we have our answer for the area of the shaded region R. Okay, so there's a bit of integration of parametrics there, a bit of partial fractions there. Okay, and So that's important for us to understand. So there we have the answer to that question number 5 from the June 2024 Pure Mathematics P4 paper. Other questions from this paper we will find in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of parametric integration I'll put in this playlist over here. I'll also put a playlist here for partial fractions, as that's part of this question as well. And you can subscribe to my channel by clicking on that link. Thank you for watching and see you soon.